All right, guys, welcome back to this series on serverless. This is part 3. In this episode, we're going to be diving into it a bit further. Essentially, what I want to do is get things a bit more massaged out to look like they should. So we'll go through some of the code here. We'll add in some functionality. We want to write some information to DynamoDB, right? So that's sort of what we want to do. We want to write some information. We want to be able to get information. So we're going to need two routes for that, right? We're going to need a get route on our API, and we're going to need a put route on our API that will allow us to put new information to our API and ultimately into our database, or it will be able to update information as well. So these are sort of the two things that we want to have, right? API gateway, which calls Lambda, which calls DynamoDB. Now, when you're working with API gateway, it's a really, there's a lot to API Gateway. It's really one of those services that I could make a whole other video on and go into detail about certain things, but you don't necessarily have to have this Lambda function in the middle between your API Gateway and the service that you want to interact with. You can have something called service integration, which allows you to essentially have DynamoDB or whatever service you choose behind a specific route, and you create something called a map, right? A template map that says that if this happens on the API gateway, go and put this is directly in DynamoDB. So you don't need Lambda for what we're doing here, but I do want to say that Lambda allows you to have, of course, that custom runtime environment where you might want to do something else with the data rather than just directly write it in. So there is a use case for either or, but it's important to know about API Gateway's integration for Lambda and also its direct service integration with other services. So that's something that I would recommend having a look into further if that interests you. So what I want to do quickly though, before we quickly add in these two routes and mess with this a bit more, I do want to say that there is one thing that we didn't quickly look at in the previous clip that I want to go through right now. We did talk about SAM local invoke. Now, what I want to do now is a SAM local start API. So this is actually testing now the API and the Lambda function. This will create an API in front of our Lambda function that allows us to trigger it with events, right? So when I run this, what it will actually do is it starts a HTTP endpoint. So now we have the function mounted and running behind this API gateway running on localhost 3000, right? So what it does when I run SAM local start API is it checks the SAM template, and it's looking for Lambda functions that have the type of API. And then what it's going to do is create this for us and offer these routes for us to use that will actually trigger our Lambda function. So it's a really nice way of sort of testing API Gateway with your Lambda function locally. So now we have this mounted. So I can open Postman here, and I can just put the URL in. So I can paste that in, and I can just do a GET request against that. So when I hit that, you can actually see in the background it actually starts up, and you can see the actual execution of it happening. So I see the hello world happening here. This is the response that our function returns to us, right? So I can run it again, and you can see it's going to invoke that function again in the background. So again, you see the status here and you see the time. Of course, the time here is not going to be what it's like when it's actually running in Lambda. This is just all locally, and it's using Docker locally here, and this web server, which happens to be a bit different to what's going to be exactly running on API Gateway. But it allows you to test the functionality where I can simulate certain things, like I can pass in a body here, or I can pass in query string parameters, and I can do something with it to test the functionality of my application. So I actually get the full, the bigger picture here, which is really nice. So this is part of the puzzle about testing locally. So we've been talking about this, we're talking about building a serverless app, but we haven't really even touched on going into AWS yet and building these actual resources. And I want to keep that going because I want to show you guys that building serverless doesn't necessarily mean you have to be fully developing it in AWS. You can develop a lot of it locally, and you can have these endpoints that you work with and these services that are mocked essentially locally. And really perform a lot of similar integrations, a lot of similar tests, and a lot of similar functionality. So this is one of them, right? So we know this is working as expected at the moment with an API and a Lambda function. But what I want to do is add in a couple of tests, or a test to this, to make sure that our environment is solid, because it's really important to test your code as you're writing it, right? If you follow test-driven development, you'll write those tests first, and then you'll work on backwards from there and implement the functions. So that's something that I want to quickly do. And in this episode as well, I want to talk about Localstack and developing against services locally on your laptop. And then after that, we'll explore further and get into it. But for now, let's jump straight back into the code. So we have this function here, but we don't really have any test coverage for this function. I mean, it's very simple. All it's doing is returning something. But the concept still stands. We should aim for a very high test coverage. So we can write a test just to ensure that this is working as intended. And as we split out our code into multiple smaller functions, we'll write tests for all of those smaller functions. So the first thing I want to do is, I see that the boilerplate has given me something called test handler.js, and it's got some sort of foobar code in here for some testing. So the first thing I'm going to do, because I'm going to use jest, I want to change this to just handler.test, and that will allow jest to sort of pick it up and notice it's a test just by the naming structure, which is nice. I can remove a lot of this, and let's remove some other stuff up here. So we don't need chai. We're not going to be using chai and mocha. What I do want to do is, we generated this event previously, right? This is an event that we were able to create with the SAM CLI. We said SAM CLI generate event, and it gave us the event. So what I want to do is I want to bring this in here. So let's bring this in. Let's require this so we have a copy of it. We're going to use it later on for different things. So this is in event.json. So that will allow us to refer to this object here in event, which is handy. And so what else am I going to need to do, right? I'm going to need to install jest. That's one thing I'm going to need to do. So we can stop our web server here from our local testing. And let's do an npm install of jest. And that's going to be a dev dependency because we don't need it in production. It's just a test with. So that's installing now. What we can do is, let's go ahead and just leave this sort of similar to the way it is. We've changed a couple of things, right? We didn't call our function lambda handler. We just called it handler, so we can refer to this name correctly now. And what we can do here is, we don't need to store this in an output, and we can remove this. So this is looking a little bit better. We don't need this. What we do need, however, is an extra piece here, and we can beautify that. And that looks a little better, and we just need to add in one more here. Okay, so we're testing index here. This is tests index. So let's do test our generate response. And what we're going to bring in is from our app. So we're bringing in this file here. But what we actually need to do is export that function that we want to use, right? So if we go and have a look at our app.js, we haven't actually exported this. So we need to export this function out as well so we can use it for testing. So now that we've exported it out of here, it can be brought into this function here so we can test it. So it's not so much that we want to test this app handler, right? So these lines here, they would say, go and run all of the handler, which we don't really want to do at this point. We want to build small modular tests that we can work upon. So what we'll do is, we'll say that the output, or we'll say generate response, and we'll refer to app.generate response, and this takes a status code. And you can tell if you just mouse over it when you import it there, you can see what it actually takes. So a status code, so 200 we'll say, and a body, which is just a JSON object. So if we said like message, for example, and body, I don't know, something like that. So now this generate response constant here is going to contain that output, so we can test against that. So what we could say is we want to expect that generate response status code, and we can say 2 equal, and here we could just say like 200, right? So we know that, and we could also do another expectation here to say that the body should, and maybe we can in here actually put in this JSON object, right? We're just sort of testing that it returns valid content, right? And of course, generate response is very basic now, where it just returns this anyway, but we will definitely build on this as we go. And it's really good to sort of build these tests in place before we start getting too much into building out our application. So now that we've installed Jest, we've built this out a little bit, what we can do is go into our package.json. And you can see here that we have our npm test will run Jest. You can see Jest as a dev dependency. So we should be good to simply just run npm test. And this will execute Jest, as you can see. And it will run here. And you can see it's failed. And what it failed with was this nice sort of output here. And it says like, hey, I got to this line. And this was the expected result. But this is actually what I got. Now, what we're doing here and what this error is nice because it's actually showing us that we are, in our function, we're actually stringifying it. We're using JSON stringify to stringify this JSON response because that's the way the API gateway is expecting it returned. But in our literal context here, we specified that we actually wanted to have a JSON object returned. So that's easy to fix. So all we do is go back in here and we can just say JSON.stringify, and just wrap that in there like so. So then we just close that out again and we're done. So if we just run test again, we should have a valid test now. And we do. We have a successful pass. You can see it verifies a successful response. So this is a nice little touch. We're able to go in, we're able to build a test pretty quickly just for one single function. And as we add more, we can come in here and build on this further. So this is a really good fundamental place to start. So we have our test now, and we can pretty this up and build on it as we need. But what we should really work on is how we're going to incorporate our database into this, right? We want to have API gateway, Lambda, Dynamo. We want to have all these pieces in here. So what I need to do is I need to work with the SDK, right? When you think about I need to integrate with actual services, I should work with the SDK in this sense. So what we can do is we should require these in. So what we can say is I want to, if I can say AWS with X-Ray, so I have snippets, and these snippets allow me to bring up bits and pieces of code that I've saved that I find useful. So definitely take a look into the snippet context in VS Code if you're interested in saving little bits and pieces. That makes it really simple to work with, and you don't have to remember everything. So I've also put here a little line that I need to run to export this X-ray context missing environment variable if I want to run this locally. Now, X-ray is something we haven't talked about yet, and we will as we work more with our serverless app moving forward because it gives us a really, really nice view into what's happening in the bits and pieces in our app. We can do things like distributed tracing, so we can see how our application is talking to each other. And we can also pinpoint where there might be issues with latency or we're getting 404s or certain things like that. It's a really nice way to visualize and monitor your application. So this is going to be requiring in the AWS X-Ray SDK, the core version of that, light version. And then we're going to be bringing in the actual AWS SDK. What we're doing there is we're wrapping all of our calls from our SDK in X-Ray. So we should be able to see, as we talk to our services, we should be able to see that connectivity and see that sort of service and that application come to life in the X-Ray console, which is really nice. So that's pretty much what I need to just bring in the SDK for AWS and also X-Ray. What I want to do now is I want to make a DynamoDB client, right? I want to use DynamoDB. This is something I want to use here because we're going to write some information to DynamoDB. So I have another snippet here, which just is DynamoDB client. And this is, of course, out of the AWS SDK. So you can see that here, AWS, DynamoDB, and then we're going to use the document client. So the document client is a simplified version that allows you to do sort of simple queries and simple puts and gets. It's very sort of straightforward. Of course, you have some batch capability as well. But it's a really, really nice user experience. It's really easy to use. You don't have to define anything fancy up front. You just go. So it's really fast. So the region I'm going to be working with is EU West 1. You don't have to specify a region. You could just let Lambda decide this. Whatever region it's running in, it will also use. The endpoint that I'm going to be using for testing is localhost. And you might say, how the hell are you going to be running DynamoDB locally? So we're going to talk about Localstack here in a moment. But we'll get to that in a minute. And I also have this convert empty values here. So this will allow me to, if I have an empty value that I'm passing into the database, it will convert it to a null and allow me to basically put in undefined, but that won't actually enter the object in. It will just say, oh, cool, this is undefined, so I'm just not going to write it into the database, which is quite nice. All right, so that's the document client that I've brought in. You can see it's not used yet. So what I'm going to make is a function that allows me to put something in DynamoDB. So Dynamo put, maybe. I mean, that's a pretty basic name. And what's this going to take? It's going to take a parameters. Let's just say it's going to take a params object. And what this should return is a Dynamo document client. So document client. And this document client has something called put. And what we're going to do is pass those parameters into put, right? We just want to put something in DynamoDB. Now, with the JavaScript SDK, what you can actually do is you can just specify that you want a promise returned from that. So I can say, like, go and do this put function here, like run put and return to me a promise that will be pending at this point in time. So what I want to do is actually, I really want to use the promise functionality of async await in this application because I think it's a lot nicer than callbacks. So I'm going to just keep our function very simple and just run this, right? So we want to return the promise from a put request with our parameters in here. And our parameters are going to be things like the table name and also the item that we're putting in the database. So now we have this functionality. We can put it in our code down here, right? So what we can do is we can simply test this out first. That's the best way to go. So what I want to say is I want to say await and Dynamo put and the items that I want to pass in here. And of course, this is going to come from the query string or maybe the route or the body of our request that we're actually sending to our API. But for now, I'll just keep it, we'll hard code it and we'll work on that shortly. So table name is going to be something we're going to have to pass in, so we don't really know the table name yet, and what item we want to pass in. So the item is going to be what actual thing we want to put into the database. So as you know, it's a NoSQL database, so we can just say that we want to pass in an ID, and I'll make that 123, right? So very, very straightforward at this point. But this is where we get to a point and you say, okay, that's great that we want to put something into the database, but how on earth do you know the table name? You haven't created a table, you haven't done anything yet. We haven't even connected to AWS. This is where we use something called Localstack. So let's just flick over to GitHub real quick and you can check out Localstack here. So it's a fully functional local AWS cloud stack. So what's really nice about this is it actually spins up the following sort of APIs on your local machine that you can use. Now, these are not identical like for like of AWS APIs, right? But these are very, very close and they'll allow you to simulate a lot of the functionality that you can from the SDKs, right? So if I want to put something in S3, I can simulate it locally. I can simulate Firehose, SQS, SNS, Elasticsearch, all these things that you would work with in AWS, you can simulate them locally. So DynamoDB is what I'm going to be using here. You can see it's going to be on 4569. And so you can see in my code here, I've actually said the endpoint I want to use is localhost 4569. So when we're in prod, we wouldn't even have this endpoint specification here because it would know to talk to the DynamoDB APIs as specified in the SDK. So how do I use this? There's a couple of requirements here that you can do to spin this up locally. Like you can go through this. But really, everything these days is just so much easier to spin up in Docker, and you don't have to worry about installing Maven and all these things locally. So it's a lot easier to use Docker Compose. So you can see that it just says Docker Compose up here, but it says if you're on a Mac OS, you should run this command here. So this temp directory, and just specifying a temp directory here that it can use to store things. You can specify the services that you want to bring up and the default region and all that sort of stuff. So we have that in our Docker Compose file up here. So you can see the Docker Compose file that we're going to be using. And we can just spin that up now. So if I just navigate over to that, so let's go Localstack. And all I want to run is this TMP command. And that's going to spin this up in the background, right? So if you do a Docker PSA, you can see that's actually running now. And if we have a look at the logs of that, you can see it's starting to spin up and it's bringing up some of the ports and some of the services that we might want to use. So that you can see starting DynamoDB. And that's sort of looking like it's pretty much ready to roll. We do actually get an interface that we can look at Localstack and the services and everything there on port 8080, but we don't really need to interface with this. We can just create a table and then we can just start writing some data to it. So that's pretty cool. So one thing I would need to do next is I would need to interact with this. Like I want to create a table, but I don't want to create a table in AWS yet. I just want to create it locally, right? I need to test that this works. So what I can do is I can run AWS Local. Now, AWS Local is a command line tool that is referenced here on the Localstack repository. If you scroll down, you'll see that there's something called AWS Local. And it's actually the CLI, and what it's actually doing is basically just wrapping this command here for you. So AWS --endpoint URL lets you specify an endpoint other than, of course, the AWS API. So therefore, you can use it locally. And so AWS Local just shortens that for you, so you can call those things. So what I can run here is AWS Local DynamoDB list tables, and you can see I have no tables, right? So it's actually talking to that API in the container now, and it's going, okay. You can see you have no tables created. So what I want to do is I want to say DynamoDB create table. And what I want to run here is this create table command. Now, I want to create a table called tasks, right? A very basic thing here. And the table is going to have some attributes to it. It's going to have simply an ID, like that's going to be what we're going to be using. So we're going to be sending information in through our API gateway. There's certain tasks, like have I done the washing? Have I fed the cats? Have I looked at enough memes today? That sort of stuff. So I need to specify the definition for that and also the key schema. So the key schema is going to be really simple. It's just going to be the ID. It's going to be the hash key. And all I really am going to be using is the ID to differentiate the items in the table. And they can also, of course, have some other properties that I'll send through, such as is the task complete or what was the name of the task. And I can also specify some write and read capacity units here. We'll talk a little bit about auto-scaling for this later on down the track, where applications built and fully running, and we define all that in CloudFormation. But for now, we can just specify this. Now that creates us the table. So here you can see the output of the table, and we have a table fully created. You can see the name of it is tasks here. It's got an on that's fake. It's got everything about it that looks like it's a real table in AWS, but it's actually all running locally, which is quite nice. So now I have the name of the table. It's called tasks. So I could call this DynamoDB put command to actually insert some data into the table. If we have a look, if I do DynamoDB query, so I'm going to actually query that table now, and I'm actually going to ask for if there is anything in there. So you can see down here, I'm actually doing a query, and I'm saying find me an ID where ID is 123. And there's no items returned to me. So that's quite nice. I know that there's nothing in there yet. So what I could do is I can call this DynamoDB put command to actually write to this task and actually insert that item in there. And that should give me a valid response. So let's go ahead and give that a whirl. So what I'm going to need to do first, though, is actually install a couple of these things. I haven't even npm installed this yet. So let's go ahead and npm install the AWS X-Ray SDK. It's going to be part of our production package here. We're going to need this once we actually push this to Lambda as well. Now, one thing you don't need, oops, I did that in the wrong directory. npm install of the AWS X-Ray SDK. So one thing you don't really quite need to package up is the AWS SDK itself. That is available in Lambda. But if you do want the latest version of it, you should package it up yourself and include it in your artifact that you put up in Lambda, because you're guaranteeing the version that you get here, whereas the one in the Lambda runtime environment might not be the exact latest one. So I'm going to include it in here. So we can go ahead and run our app now. Let's just have a look what happens if we just run this locally. I'll probably get no error. That's good. Okay, sweet. I was expecting an error of some sort. That's because we didn't actually even call our function, to be honest. We just loaded it into memory, so that's a bit of a silly one. So let's just actually call our handler down here and see if we get anything. So, all right, we got a callback is not a function, which is expected because this is not a function in the current scope of things. So let's just run that again. We didn't get anything. So nothing is good in that sense. So if we run our local DynamoDB query against our database, we can see we have an item now. We have one item in our database. So we know that our functionality of our DynamoDB put is working as intended. So we were able to test all of that and run that. So what we could do now is build a test for it and make sure that all works properly. So that's a fun piece as well. So I'm going to uncomment this out. And again, I could have tested all of that by executing it via Postman and calling my route, by doing an invoke, but I chose to run this file locally. So it's important to think about all the different ways that you can execute your things when you're testing them locally, but this is just, for this purpose, it works fine. So that's pretty much it for this one. We've talked a little bit about Localstack. I really want you to guys to go and have a look at Localstack, do some reading, spin it up. It's really, really easy to use. It allows you to get a really nice insight into testing your applications in a serverless context or not. You can do it locally, or it can be part of your CI/CD pipeline. It can be part of a whole broad range of things to have these services mocked and be able to send things around. So that's pretty much it for this one, guys. In the next clip, we're going to be extending this further, and we're going to be building it out and doing our put route and our get route together, and we'll get that database item out that we were able to write, and we'll finish off this handler a bit nicer here as well. All right, cheers, guys.